Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. Right, so this is a AOC monitor here. The model number is a E2236V WA. Now this monitor is completely dead, doesn't power up. So it's got one of these awful bloody touch buttons, right? Touch sensitive buttons. I hate those bloody touch sensitive button systems, right? Down here as well. I absolutely despise them because they always give problems. If you've got any like ambient electrical noise or high, strong Wi-Fi signal, stuff like that, sometimes it doesn't actually respond to the button presses. So I found that when I got my Wi-Fi unit right behind the monitor, it wouldn't even respond to any button presses, stuff like that. It was weird stuff. So I absolutely hate these kind of touch sensitive buttons. I just don't like them at all. Anyway, this monitor's completely dead, and the idea is to try and get this thing apart and hopefully try and find what's wrong with it and fix it. I've got no manuals, no service information, nothing at all. So we're just going to be playing this completely by ear and seeing if we can figure out what's going on with it. If I can get the cover off, of course. That's the first challenge, is to lever the cover and get it loose without breaking the screen, hopefully too. Alright, so let's try over here. Let's try and get a corner started. And hopefully we can break this out. Here we go. There's a wire there which I might need to take off or something. Pop the speaker out. Okay. It looks like there's a sensor thing over there too. So be careful if there's a wire right there. Yeah, you can see it in the chat too. Just there. So watch out for that. Oh, it's just come off anyway. It's unplugged itself. Cool. Come on. Okay, that's half the job. Getting into the damn thing. So there's the speakers, bottom there, and that little plug there, which I'm going to have to figure out how to put back on again after, which goes onto here. So that's all the touch sensor assembly. Who knows, there might be a problem with that. It might be why it doesn't turn on because it's not touching, not sensing touch, I don't know, but when you plug in the power, there's no activity whatsoever, it's just nothing. So let's try and get this screen out somehow. Now the whole assembly is going to come out, of course it is. Wouldn't come out before. Something stopping it, what's stopping that? Not sure. Here we go. Right. So USB plug on the back. Okay. So yeah, I should have taken the back off. It must have just been stuck. But we've still plenty of shielding, give it that much. Power supply is also going to be in this section here somewhere. Looks like I could get to it from the front. I've got to take the panel out by the looks of it. Because that's all riveted on, so I'm not going to be getting through that way. So let's take flexes out of here. Make sure, make a note which one's which actually. They could easily get mixed up. Bit of mark, guys. Looks like they're about the same length, so you could easily get them back to front. Oh, my pen's coming apart. Never mind. Come on, got a 2 on there. Okay. Must be more than those wires, obviously. There's this flex here as well. Not quite sure that one goes in actually. I think that's a connector. Okay. Yep, there we go. Just a couple of screws on the end. Doesn't actually be a lot of holes in the frame. I just have 2 screws. One of them's loose. Right. I'm pretty sure that's all it is. Yep, it is. Okay. Put the panel somewhere, don't break it. Okay, let's pop this panel here off and should release that. Yeah, that's what's holding that. There we go. So let's get these. Sort of it runs around the back. It's interesting. So trying to plug those in and out is going to be a bit tricky. Potentially, if I can loosen them off, it'd be alright. So that's a speaker one. And that's a power one, which goes back into there, which then comes back over to that board. So the power supply is going from here through to there. Don't make it easy to get to the plugs, though, do they? Can't pop off. Probably working around this metal work as you're likely to cut yourself because there's also some sharp edges. Let's try and get this side off instead. It's probably a technique of getting this in now. Is that your plug? No, it's not. It's a bloody terminal setup. Okay. There's a plug over that side. Okay. Let's also take down behind that board. Right, that'll make it easier, right? Come on. This hasn't been powered up for a while, so it should be all pretty safe. Right. Let's get this out of here too. Sort of taped behind the bloody board here, just to be all annoying. I'm not quite sure what that board there is doing. Obviously had those cables that went up to the display, so they're probably backlighting. Well, I guess this is a backlight driver. Right. Let's have a look. Can I see anything obvious? No. Nothing obvious. I hate that. So it may not even be a power supply problem, it might be something else. Well, I'm hoping it's a power supply problem. Those look alright. Right, let's just make sure these caps are discharged fully before I start probing it with my meters and risk blowing them up. So, nothing there. Just got to find them all. Nothing there. This hasn't been powered on for quite some time, so it should be pretty much dead anyway. But I just want to be sure, just in case there's a residual voltage where something's not actually discharged because it's been shut off. I don't want to blow my meter up. Obviously, doing this sort of stuff, and if you've just powered it up, for example, it's likely to have high voltages on this board. So in that case, be very, very careful. Yeah, everything's completely dead. Don't think I've missed any. Yeah. Okay. So I definitely know voltages on those caps. Assuming of course this is working. Should verify it on my power supply. That'll tell me. Choice verify. Yeah, it's working. Okay. So this meter's got its low Z range, so it helps to discharge capacitors if there's any residual voltage. Handy for that. Let's start checking. See what we find. It's starting right inside, I think. That's supposed to be what? 100 UF 25 volt. Yeah. 1.7 ohms though. Cheers, one. What's that reading so far out? Probably doing in circuit testing. It's got the same value as this one, so suspicious. But probably doing a circuit, you never quite trust the bloody readings you get anyway. 50 millifarad, 0.5 ohms. 680 UF. Yeah, this in circuit testing is just not working very well. Not on this thing anyway. I might have to change meters. Don't think I'm trusting these readings. Okay, let's try with this meter. If it's not dead. I think the battery's flat. But it's just my lighting looking really bad. Looks a bit dim. Let's check this one. 0.44. 100 UF 450 volt. Yeah. Well, I was expected to be a bit lower than that actually. .17. Right. One ohms, getting up there a little bit. What was that one? It was low voltage, might be right. 10 UF 50 volt. Yeah, it's probably okay. .6, yeah, it's definitely right. Zero. Zero. Interesting. Not sure zero is right. Three. Might have to go around checking for shorts on that rail. 1, 2. And 0.76, again, not that bad. There's nothing obviously bad, really. Yeah. Apart from that, having that extremely low 0 ohm resistance. What's in that rail? There's a cap across here. It's on a 5-volt rail. Oh, sorry, that's not. It's common ground. So I'm looking at what's that rail there. Diodes going to there. There's a fuse, and that's on the 5-volt rail. Yeah, there's a 5-volt rail output, and there's a fuse across here. Well, fuse looks alright. But interestingly, just here, it looks like it's been getting hot on that coupler, auto isolator. Or is it just flux residue? No, it's just flux. It's probably just bad soldering, maybe it's reworked. Yeah, it's obviously reworked. The solder looks a little bit different. Okay, so why would I be getting 0 ohms across there? No, it's no short, it's okay. It's fine. So, there's nothing obvious on the board, really, to say it's got a problem. Another fuse over there, let's check that one too. Yep, let's double check this one with us. Okay, it's fine. So, I think the next thing I'll do is put it back into the unit and test the voltages. Otherwise I could check diodes and stuff like that. Nice easy thing to do. Put it back over here so you can see it, I suppose. That's looking suspicious. These are definitely looking dodgy, actually. What are those things doing? In regards to the centre tap of the transformer, I'm assuming it's centre tap. And there's a capacitor across there. I think one of those diodes might be gone. Possible. And that's on that side. Interesting. I think there may be a short. Where is it? That's the question. There's a low drop across these. Well, it's a bipolar anyway, but yeah. Getting some weird readings from there, but again, because it's in circuit, it's almost like the emitter collector shorted on this thing. I'm getting the same reading both ways. Now, is it there or is it something around it? Right. Getting the same reading across it, resistor. There's a diode there. Is that what's blown? Probably not. An inductor there to there. Maybe it's a feedback from an inductor. Right, let's probe some voltages around here. Now this is all live right now, so I'll be really careful not to touch any of this in this section here, especially that bit inside that line. That's going to be dangerous. So I'll try and keep my hands away from there and not be my usual complacent self and be a bit slack about where I'm sticking my hands. So let's try over here first. That's audio pins, don't care about any of those. Should be 14 volts. Nothing. Nothing at all. That's all commoned up. That's grounds up there, so let's make sure across those rails, because I stay rails. Definitely nothing there. Does have an on-off option too, but just measure here. So we've got 5 volts. No, nothing there. Let's go on-off pin here. Nothing there. Yeah, it's looking pretty dead. It does look like a power supply problem of some kind. Yeah, there's no voltages in here. Alright, so let's check a bit further back. What do we have around here somewhere? Nothing. Nothing at all. Okay. So definitely got AC coming in, but it looks like it isn't doing anything over here. Not sure which windings are supposed to be using. Okay, there we go. Get 300 volts DC there. So there's some life on this side of the transformer. See anything over here, which I wouldn't expect anyway. Yeah, this side seems dead. This is where my inexperience of Switchmode supplies comes in really useful, doesn't it? There seems to be nothing on this side of the transformer. Just trying to figure out how this thing bloody works, because I'd say I'm not good at Switchmodes. It's not my strength. So let's check some diodes on the other side as well, since it seems to be completely dead and not switching. At least that's the way it appears. Let's just check these diodes. Come on. There's a diode, isn't it? Yes. Yeah, it looks alright. So there's that one. So there's that one. So I'll still come back to this area here, aren't I mean, that looks the same both directions. So with DC coming in here, that leg of the chip, and over to there, which has got a jumper wire, comes to here. So the common negative is going there. Got diode that side, diode that side. Sorry, resistor that side. Let's check and see if that resistor's got any resistance or not, in case it's opened up. $100K, that sounds like a reasonable value. It's marked at 100K, so yep, that's fine. So the positive comes up here, jumps to this side. So it does have a DC on that side of the transformer. Again, I'm not great on these bloody things, these switch modes. So the DC going there, and you've got the resistor going to there from the DC side. Got capacitor across there, resistors to there, jumps to that, which is the supply for that chip. So it is showing a DC directly across those two outer windings there. So we've got negative chip, capacitors there, feedback there, also a couple of feedback, which is a positive smoothing here, capacitor across there. So that's a Zener diode, I can see it's marked as there. Okay. So it's obviously power supply. Yeah, so that's a higher voltage. So that's clipping the input and setting a voltage maximum there. So it's pulling this up through a Zener in order to drop the voltage. Okay. I'm just not sure that the input side's right either, that's the problem. So yeah, I suppose I might just try lifting a diode and see if I can determine if one of these diodes is bad. Because that could be why that side's dead, it's because it's loaded down. We'll go for that first. So, where was I looking before? So those ones on it. Yeah. So these are looking like a dead shot, don't they? They really are. What's that capacitor right there? So which part is causing that short? And that's a jumper, so that should be right. We got this, which is measuring that, which is the same as I'm getting through the jumper to here. Alright, yeah. Diode there, which is measuring oddly as well. Is it a feedback from this inductor? I think if I take that inductor out that's there, that might give me a break in the circuitry. That might help me narrow down where it is. Let's get my desoldering I'm going to do. Bloody lead free solder. Get my extractor thing going, it's pretty stinky. Okay, it's inductor out. See if that changed anything. has changed something because I wasn't getting the same readings as before. So that transistor looks like it's probably alright. Still seeing a short across here though. And check that diode. There. The diode there is looking okay. So I'm thinking there's probably a short either on that capacitor or one of these diodes. Nice big ones. So let's lift one of those out. I have to lift them both out since I've got the gear right here. Might as well just lift one end out. Check them individually. That one's shorted. Yep, that one there's shorted out. Cool, actually found something. So, looks like that diode there is blown. So let's get the thing out. The other one looked okay. There's a shock key. It's very low resistance, so it's only like 0.15 ohms or something, so 0.15 volt drop, sorry. So it's, I don't know if I've got anything which I can use to put in there, actually. Yeah. Well, what the hell is this thing? SR510. I have to look that up. Okay, so we found this diode here is blown, which is a SR510. Now the only diode I've got which is likely to handle it is a 6A6, which is only a silicon diode though. So a silicon rectifier diode. So it's not the same. This has got a different voltage drop compared to the silicon, which means it's going to dissipate more heat compared to a Schottky diode. So we'll chuck this in parallel with the original Schottky, and with a bit of luck it doesn't go bang. Or maybe in your perspective, maybe with a bit of luck it does go bang, I don't know, but we shall see if it can manage it or not. You can see it's a nice chunky diode compared to the original, but we'll give it a go. No harm in trying. So let's just power it up as it is, like this. I'll chuck a power cable in there, and I think I might put the danger side away from you. It might be a good idea. Let's see what happens. Turn the power on. Make sure I set up for measuring voltage, not diodes. Don't want to blow the meter up at the same time. Okay, power is on. Let's see if we get anything. There's ground right there. I'm getting something. 5 volt. Oh, I've got a 5 volt rail now. So that's a good start. I have a 5 volt rail. So that might actually work. Is that diode getting warm? Not yet. Oh, maybe slightly. I'm not going to rule that out yet. Let's turn it back on and check temperatures. I actually approached Fluke about getting a thermal camera from them, and they said that they couldn't supply me anything, which is a bit of a shame. I was hoping I could get a free one out of them, but they said they were willing to help me and, you know, obviously let me buy one from them, but I wanted a free one. So there is some heat there. It's about 37 degrees, 38 or so. I can't tell which part it's coming from because I need a better thermal camera. So if Fluke or anyone like that wants to give me one to do videos and help demonstrate your product, please get in touch. It's always worth a shot on it. Okay, well, I can't tell in which one it is. Can't tell. Because this doesn't have the resolution or the accuracy of the angles and stuff, so I can't tell which one it is. Because it doesn't actually align until about 30 centimeters away. I think it's the left one. It seems to be more closely aligned to the left one, which is what I'd expect, which is the one I just put in. That's what I'm thinking it is. Pretty sure it's the left one. So if I just use purely a thermal view, no overlay. Yeah, it's the left one. I can just see a slight gap between the two. They're both generating heat. The left one's generating more, which is what I'd expect. So I'll make sure before I start touching things. Nothing on that one. Oh, I've got to put that bloody... I've got to put this back in, haven't I? Inductor. That might be why the 40 volt rail didn't work. Anyway. I should do that, shouldn't I? I'm sure this is dead now. 17 volts that side, yeah, that's alright. Can live with that. Yeah, okay. Let's put the inductor back in. That's a silly thing to do. Forget to put that back in. That might affect the outcome. Solder. Let's try it again, shall we? Now I've got all the parts back in. Okay, check the 5 volt right again. That's there. And we've got 14 volts over here. And we do, we've got 17 volts now. So that inductor's also, that's for that supply over there. 14.5 volts rail, which is sitting at 17. So it is working. Okay. I think we're good. But I think I'll probably try and get the right part. When I get the right part in time and it arrives in time, I'll put it in. So I best order it now. It'll be discharged by now, so actually, I've put that in dust. I should double check that, shouldn't I? Make sure the side's definitely dead. Still 17 volts on that side. That's working more then. Yeah, still 17 volts on there. And I'll discharge it through here. 17 volts isn't dodgy, but it might just mean that the capacitors are still charged up a bit too much. Yeah, I don't. It's probably right. Okay, let's put this thing back together. See if it actually works. So let's put this back together. Put lighting back on. So I think I'll consider this a temporary repair until I can get those proper parts in. But I still want to hook it all up and fully test it all, be sure it's going to be okay in case there's some other problem. But the power supply rails are there. You do have to wonder though why that part failed though. You know, you always have to think, well, what made it go in the first place? Was it just age? Was it stress? You know, is there some other fault which I haven't identified yet? I'll take that back down again, won't I? So to take down for a reason. In there. I think using a metal screwdriver around potentially high voltage circuit boards is probably a bit dodgy actually, but yeah. I do actually have an insulated screwdriver set somewhere. Probably should be using those. I actually need to get myself a proper set of electrical screwdrivers, like a proper fully insulated with an insulated shaft and stuff like that. I need to get some of those. I've got a feeling I did have some. Pretty sure I have had some. Now I'm just wondering what I've done with them. I'm taking this out because I want to take this back down again. So obviously done so it doesn't rub on the back of this board here. But it'd be nice if this actually works. Okay, that's that part. It's got these little rubber pads. I'm not sure it's supposed to be on that point though. Weird. So that's on there. I thought that'd be there instead. Looks like it's moved. Strange. Anyway, does that line up that way? Kind of does. I think there's in the wrong place. I don't think it's supposed to sit on top of it. I think it's supposed to sit on there. Right. So let's put the screen back in. And mustn't forget to put that piece back on as well. Might only got two screws to hold onto the frame. And yeah, that's sitting a lot better on now, so I think that little rubber pad was in the wrong place. Back on. Wherever that goes. It's on the bottom piece first. Yep. Cut it back in. We've got these flexes we have to put in the right places. Tape these down. Here's extra, that's free. Right, they can have that for free, don't worry about those. Care's always a bonus, isn't it? Right. Put those flexes in. Hey, I'm sure the left one's fully in properly. Just check it. Yeah, it's in, that's right. Here we go, better. Right. Should we power it up like that? Oh no, I need the bloody casing on there, so let's get it in there. I think that board's supposed to be stuck in afterwards. There we go, it's looking better. Almost went in there. Right, it's in. In theory, I think that should work. Let's give it a try before I put the top cover back on. Okay, it's stick magnets on the back, get them out of the way. The speakers are keeping getting in the way of everything. Right, will it work? Here it on. Yay! It goes. Excellent. Touch sensing working or not? Yes, it is. Come on. Menus. Well, touch sensing for turning it on off is working. Choosing menus isn't working now. Yeah. Like I said, I've got lots of noise in this room, and it may be a manual will come up once it's got a signal on it. Yeah. So it's kind of working. Let's look at input. DVI, VGA. I don't have a supply I can use for that right now. I've only got HDMI. Well, at least it seems to be working. It powers up, that's the main thing. Cool. I think I can call that a fix.